Demonstrating the central limit theorem. The central limit theorem states that for samples of size n from a normal population, the distribution of sample means is normal, with a mean equal to the mean of the population and a standard deviation equal to the standard deviation of the population divided by the square root of the sample size. The standard deviation of sampling distribution of x bar is referred to as the standard error of the statistic. Okay, so the standard deviation of the sampling distribution is also referred as the standard error of the statistic. For suitably large sample sizes, the central limit theorem also applies to populations whose distributions are not normal. For samples of size n, the distribution of sample means is normal, has a mean of mu, has a standard of standard deviation over a square root of n, where mu and standard deviation represent the mean and the standard deviation of the population from which the sample came. If samples of size n are randomly drawn from a population that has a mean and standard deviation of means are approximately normally distributed for sufficiently large sample sizes, for instance, n is greater than 30, regardless the shape of the population distribution. Mean of the sample means is the population mean. Standard deviation of the sample means is the standard deviation of the population divided by the square root of m. So, for you to understand the concept clearly, let's proceed to our first problem. Suppose a population is a mean of 180 with a standard deviation of 20 pounds. Find the mean and standard deviation of the sampling distribution of the sample means for sample size. A is equal to n. Okay, so going back to the formula, we have here this one. We have to make use of this formula. So just replace this by the given 20 pounds and your n is already given as 50. Just simply 20 divided by square root of 50 is 2.83. So next is if once your n is changed, so 20 divided by square root of 200 is equal to 1.41. Suppose the population of yardsticks manufactured at a given factory have a mean length of 36 inches with a standard deviation of 0.11 inches. Find the mean and standard deviation of the sample means for sample sizes shown on the table below. Round off your answer to 4 decimal places. Complete the table. Okay, how are we going to solve it? Remember our formula. This one is equal to standard deviation over square root of n. So just simply replace this by your given, which is 0.11. So simply 0.11, for instance, let's do number 1, divided by the square root of n, which is 50. Then it's gonna be 0.0156. Okay, this one. Just replace 50 by 200 by 350 by 800 by 3200. Then perform the indicated operation. Where did we get 36? It is already on the problem that 36 is our mean length or mean. Okay, just do the independent practice. So suppose the population mean for the SAT score is 550 with a standard deviation of 75. Find the mean and standard deviation of the sample means for samples of sizes below on the table. Round off your answer to 2 decimal places. Complete the table. Okay, I'm gonna do number 1 for you. So just the mean is just 550, then write 550 here. And for standard deviation, going back to the formula, over square root of n. So standard deviation of given is, we have 75 divided by square root of 50. 75 divided by square root of 50. Okay, it's gonna be, again, this one is 550 up to this one, up to the last number. Then this one is 10.6066, or rounded off to 2 decimal places is 10.61. Okay, so just you are to do from numbers for this one up to this one. Okay, so just answer this. Okay, for explore activity, solve the problems and choose the letter of your answer on the right side that best correspond to your answer. Write your answers on the numbered boxes. Okay, again, going back to the formula, we have this one is equal to square root of n. So in number 1, the given is 20, just divided by square root of 50. We will have, the answer will be 2.83 or 2.8284 or 2.83. 2.83. What number or what letter does 2.83 represent? It is letter I. Then write I here. Okay, so again, we already have our answer in number 1, which is letter I. Let's do number 2. In number 2, the unknown is this one. So the formula will be is equal to square root of n. So let's derive the formula first. So just have a cross product. So we will have this given times, it's gonna be square root of n is equal to this one. So your answer is 4.2 times square root of 80. Okay, let's try to press it on the calculator. 4.2 times square root of 80. On my calculator, it says that the answer is 37.5659 or 37.57. So it is letter A. Then write letter A here. Okay, you are to answer numbers 3 to 8. Okay? So thank you very much and God bless you all.